खराब हो जाए।
Hello, sir.
Yes, sir.
Sir, am I audible, sir?
Yes, you are audible, sir.
Okay, sir. Thank you, sir.
Yeah.
This voice is sufficient, sir?
Yes, it is clear and audible, sir.
Okay, okay, sir. Thank you, sir. Let me just check the PPT presentation. Just my updates. My laptop is updating right now. Within a 2 minutes, I will just on the presentations. Okay, sir.
Okay. I've given a right to as a co-host to you, so you can share.
Yeah, yeah. Actually, from my laptop, give the right of host to my laptop, sir. Right
Yes,
now, I'm
sir.
joining from laptop.
Yes, sir. Yes.
Yeah.
Good evening, all the participants. We'll start in next 2-3 minutes so that all the participants can join them. Shinde sir, could you please check? Shinde sir, I have given you the rights as a co-host.
Sir, am I audible, sir?
Yes, you are audible, sir.
Okay, and my screen is visible, sir?
It is visible. Will you please make it in a full screen?
One second, sir. Huh? Sir, am I audible, sir?
So you are audible. Just make the presentation full screen mode.
Sir, shall we start, sir?
Yes, sir.
Hello,
Please.
sir.
So there is some background noises there.
Now, sir, now is it clear, sir?
Yes, sir. It is.
Is it fine, sir?
Yes, sir. It is. Yeah. So thank you. So good evening, all the participants. We are really sorry from our end. We had some technical issues. Now we have solved and we have resolved the same thing. So today we have a session by Mr. R.B. Shinde. He is a completion automation trainer and assistant professor with over 14 plus years of specialized expertise in industrial automation, mechatronics, electrical, electronics, instrumentation, and Industry 4.0. He has successfully conducted corporate trainings programs for renowned companies such as Mahindra and Mahindra, Bosch, Labor, Times of India, etc. Apart from the different trainings, he has installed different automation projects for the agriculture at different industries. He was also training different undergraduate students over the automation, focusing on the social aspects of the automation, focusing on the agriculture projects. So, as a good experience in the installation of different automation projects in agriculture, I request Shinde sir to start this session. Sir, please.
Okay. Sir, thank you so much for brief introduction. First of all, I would like to thank you, the CSMS, Chhatrapati Shahu College of Engineering, for providing me the opportunity. Also, I would like to thank you, Dr. Principal Dr. G.B. Dongre sir, Vice Principal and Head, Dr. Devendra Bhuyar sir, and co-coordinator of this program, Praveen Wankade sir, for providing me the opportunity. So, as sir introduced myself, since almost last 10 to 20, 12 years, I am working in this domain, that is automations. So, when we talk about the particularly the agriculture automation, at that time, we must think what is the difference between the industrial automation and the agriculture automation. If you think about the industrial automation, you will find there is an revolutions in the factory automation, that is industry 1.0, 2.0, 3.0, 4.0, and now currently industry 5.0 era is going on. But at the same time, when we think about the agriculture, definitely there is an revolution. Before some years ago in our country, there is green revolution happens, and due to that green revolution, the supply or demand of food is completed because of that green revolution. But nowadays, it is time to move on, because as you know, we are the largest populated country in whole world. To fulfill this demand, it is very necessary to use the technology in agriculture. So I have make my presentation in two parts. The first part is related to what is the agriculture automation parts. And second one is, as we are the faculty, how we can implement this automation. Now see here, if you see, one second. Now, if you see, here I have made the overview of agriculture evolutions. The first one is the traditional farming. Second one is the transition from manual to mechanized farming. And next one is the role of automation and digitization. Here in tradition farming, we can see here the historically in traditional farming, the mostly manual and animal based farming methods we were used, and because of that manual and the animal based farming, we get a very less production in agriculture, and also the need at that time was very less. But day by day, the need and the demand of food is increasing. So our agriculture, in agriculture land, we are currently using the some mechanized system, we can say. That is, we are using the tractors nowadays. We are using some automation in irrigation system. And due to that, the production, or we can say the due to the technology, there is a production is increased in the agriculture. And nowadays we are thinking about the adaptation of automation and digitization. And because of this adaptation and digitization, there is a huge scope in the agriculture, like precision agriculture, AI-based monitoring system. I have explained in a coming slide that parts. Here we can see, if you see the comparison of farming practices, since uh, we will consider till 2024, till date, the 50% farmers are using the traditional farming method. And in our country, as you know, we are the very developing country. Many farmers having a very less land, like 2 acres, 3 acres. So almost 50% farmer are using the traditional farming. And out of remaining 40% are using the mechanized farming. Mechanizing means they are using the tractors and some little amount of technology in their farming. And remaining 10% are using the automated farming. And if you see the number of that farmers are very less. So it is a very big question in our mind. Suppose if you want to fulfill this demand, the graph should be changed. Minimum 50% farmers, or at least 40% farmers, if you use the automated farming, definitely there will be a huge change in the agriculture. Now see here, you can see here, ki when I think about when the Wankhede sir gave me the topic, that is the automation in agriculture, at that time I asked myself, ki why there is need to use the automation in agriculture? As almost in our country is developing country, why there is a need to use the automation in agriculture as our farmer cannot afford the automation or the cost of that automation. At that time, I found here this graph. Nowadays, in 20, this is 2024. And if you think about the 2034, at that time, demand of the food is going to increase by almost 1 billion. So if you want to think about the tomorrow, there is need to use the automation in the agriculture right now. So why, for what purpose we want to use the automation? Now, so see here, automation is essential in agriculture to address the labor shortage, enhance the productivity, optimize the resource use, and improve the precision in the farming operation. Now, as you know, if you go to the your village at the time of main season of agriculture, it is very difficult to find the labor for the work in a farm particularly. So nowadays, many farmers are facing the issue of labor issue here. So to supply the demand of food, it enables the sustainable practices through the smart irrigation, AI-driven crop management, real-time monitoring, ensuring the higher yields with the minimal environmental and impact. Now see here, if we are talking about the automation, then how exactly we can use the automation? Here I have noted down some points. That is the nowadays there is a very hot topic. Drones, every farmer wish to use. Even our government is also encouraging to every farmer to use the use of drone in agriculture for sprinkler purpose. Next one, that is Internet of Things. This is the technology, as almost people are technical, so I will emphasize more this technology in a coming slide. That is robotics in farming, precision agriculture, and nowadays we are talking about the future trends. And suppose if I ask you for what purpose if we want to use the drone, then we can see here we can use for the pesticides application, early detection of crop health issues, post-storm damage assessment, and the cost-effective resource management. Now, second point is about the Internet of Things. If you see I don't think so. In a technology, without the IoT, without the Internet of Things technology, it is not possible to complete the technology nowadays. So in agriculture, as if you think before 10 years ago, some students or some research scholar were written the paper or they have done the project by using the IoT in agriculture. At that time, we thought it is not possible to implement the IoT. But nowadays, after 10 years, it means that right now, if you think about the IoT, use of IoT in agriculture, many farmers, many application are using the IoT in their agriculture land. I have shown some case studies for it. So for what purpose we can use the IoT? We can use for the real-time monitoring, precision farming, resource optimization, and sustainable practice. The next technology, that is the robotics technology. Nowadays, you can say if you want to do the repetitive tasks, you can use the robotic harvester, addressing the labor shortage, increase the efficiency, sustainability, and waste reduction. We can use the robotics. And now there is a one more topic, that is the precision monitoring. The precision agriculture is a form of management concept that revolves around the process of observing, measuring, and responding to various inter and infrared variability inputs for modern agriculture. And if you ask me the definition of precision agriculture, I can say the crop management, which describes the term as a technology enabled approach to farming management that observes, measures, analyzes the needs of individual fields and crops. Now I have shown here one diagram. In this diagram, you can see, you can observe how the technology, how the automation is used for the precision monitoring. Here I have shown some sensor like a temperature sensor, water level sensor, water pressure sensor, and this sensor giving the input to the PLC. And as per your program, the PLC will execute. I have more explained the PLC part, HMI part, how exactly this part is going to play the important role in automation. I have will explain in the coming slides. Now, I think this is a very important factor I have mentioned here. That is the automation in livestock management. Yes, you know that we can use the drone, you can use the robot, you can use the precision monitoring. But apart from this, it is very necessary to see this factor, that is automatic feeding system. Nowadays, if you ask any farmer, are you earning the profit by doing the agriculture? At that time, many farmers are saying, no, we are not earning the profit by doing the agriculture. But then at that time, government or we people suggest them, why don't you try some other business which is associated with the agriculture? And that I think the associated business mainly is to milk business, we can say. So, for example, some buffaloes and cows are there. Our farmer cannot properly feed them as per the time. So, if you use the technology for feeding system, then it will be very helpful for getting the result in the form of milk. We can say you can say in the form of nutritions, and also it will be helpful for the animal health. So it is very necessary to use the automation in automated feeding system. Next one, I can say the health monitoring technology. Health monitoring system utilize the sensor and wearable device to continuously track the vital signs such as the temperature, heart rate, and activity levels of the animals. And definitely, if you care about the health of animal, it will going to play a very added advantage for getting a more and more production. Next one is the breeding optimization. Nowadays, if you ask to any farmer, okay, how much liters milk you are getting from one buffalo, at that time he will definitely tell you minimum 20 liter, 25 liters. Why this happen? Definitely this happens because of the breeding system, hybridization system. And so you must use the automation in a breeding management allows for the more accurate tracking of the genetic data and the reproductive cycles, we can say. This facilitates the better decision making regarding the mating practices, improving the quality of offspring and enhancing the herd genetics over time. The next one, we can say the labor efficiency, and for increasing the productivity, automation can play a important role. Now, my topic is particularly related to the automation in agriculture. See here, I have shown here with the help of different diagram how automation can play a role in agriculture field. What is mean by automation in agriculture? It involves the advanced machinery, software, and robotics to perform the task traditionally done by the humans. This is a very simple definition. What is mean by agriculture automation? There is a use of machinery, software, robotics. And for what purpose? For those work traditionally done by the human, we can replace this work with the help of these machineries. This includes automated tractors, robots, and automation drones for field surveillance and IoT-enabled system for the precision farming. And the goal is to enhance the efficiency, reduction of the cost, and improve the sustainability. And this is the final goal of any technology, I think so. And if I ask you, as we are the technical people, yes, many times when we see the condition of farmer at that time, many times we suggest them, you can do this technology, you can use this technology, you can use that technology. At that time, farmer many times said, this is not possible at ground level. So I asked myself how we can contribute for agriculture automation, how we can contribute making this revolution for every person, every technical person, I can say. So guys, I have made some implementation of the automation in agriculture. So as we are the technical person, we must include, we must learn, we must tell to our students, if you know this technology, how to implement, then definitely, easily, everyone can easily understand this technology and can easily implement it. Now here, I have taken some examples. Suppose if I ask you how automation can be used in agriculture, at that time you must have heard about the drip irrigation controller, pump controller, starter for on and off of the different pumps for sprinkler pumps, that is timer controller, and different sensor. It means that if you read this word at that time, you will find this technology we are using since many days. So what is this technology now? So if you ask me, what is this technology? The technology that is industrial automation, that is agriculture automation, is an integration of multiple ready-made components to perform the process operation. This is very simple definition. The industrial automation or agriculture automation, it is not a technology. We can say it is an integration of different multiple ready-made components, we can say. So which components are these? First one, we can say the switch gears. Next one is the PLC and VFD. Next one is the sensor. And next one is the motors. And nowadays, we are using that is IoT, AI, and ML. Now, if you ask me how we can do the automation in the agriculture, I will say there is no need to write any research paper. There is no need to write any, there is no need to manufacture any component. Just we need to use the component which is ready-made or which is easily available in the market. Just we need to integrate them, and by using that component, we can make our system automatic. This applicable to any industry, this applicable to any companies, this applicable to agriculture land too. So my point is that, as I already said you, I have make my presentation in two parts. That is first one, which is we already saw, which is how the technology is used in the agriculture. And second part is the implementation phase. If you want to implement the automation in the agriculture, I will suggest you guys, you just integrate these components, your system, your agriculture land will be automatic. Now, nowadays we are many times heard in IoT, different type of sensor we are using. So how we can use that such sensor? Many times we heard for making the automation, we need a PLC, we need the SCADA system, we need the HMI, we need the VFD system. How we can use? So, in a simple language, I try to explain here how we can implement, how we can use this such type of different components for making your system automatic. Now, see here, the first component I have started from the sensor. Why sensor? Because nowadays, for every technology, for a PLC, for IoT, for AI, for ML, nowadays we are you must have heard the word that is smart agriculture, smart city, smart manufacturing. And if you want to make the smart everything, we need a sensor. Without sensor, it is not possible at all to make your system smart. So I tried to tried here to how exactly we can use the sensor to make your system smart. Let's see here. What is meant by sensor? A sensor is a device that is used to continuously sense, read, and update the controller about the status of event and or convey its related parameter value, we can see. It means that it is a device. What exactly it does? It continuously sense, reads, and update the information to the controller. For example, if you are using the sprinkler system, in a sprinkler system, the valve is open or closed. How we can get the information? Definitely, you will get this information with the help of sensor. For example, next example I have taken for agriculture land. Suppose if you want to maintain the temperature of your land minimum 37 degrees Celsius, how you can maintain? With the help of sensor. So sensor, what exactly it does? It senses the data, it reads the data and gives the update to the controller. So it will sense the data, it will use the controller, and according to data, as per the data, controller will take the action and your actuator will work as per the controller or as per the data given by the sensor. And definitely the process will happen. Again, sensor will give the feedback. So this is a very simple working of sensor. Now see here guys, the next slide I have mentioned here different type of sensor. Now see here, in a market you will find the different sensor. Light sensor, temperature sensor, gas sensor, sound sensor, motion sensor, humidity sensor, blah 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 blah. Just you, what is our agenda? We need to use this sensor for making the system automatic. Now, how we can use this sensor? See here, sensor, as you know, the sensor converts the process event or the value of process parameter into the equivalent electrical signal. The main function of the sensor is that it collects the information, it collects the event, and by that events are converted into electrical signal. You will ask me why there is need to convert that information into the electrical signal, because controller understood only electrical signal. That's why sensor gets the information and that information is converted into electrical signal. For example, I have taken here, suppose there is a pressure sensor. If you want to measure the pressure at that time, the sensor will take the information in a bar. Suppose there is a 2 bar pressure and that sensor will convert that information bar into electrical signal. Electrical signal means voltage or current. So 2 bar value is converted into the 2 volt, or we can say the 10 bar pressure value is converted into the 10 volt. This is a very simple, the working principle of the sensor, guys. We can say here the status of the pump is on or off, which is get the information by sensor. If the sensor is getting a 0 volt, it means that pump is off. If sensor getting some information 1 volt, 2 volt, 3 volt, 4 volt, etc., it means that the sensor is working. In the same way, I have taken the your pump is on, the sensor will give the maximum value. So this is the simple working principle of the sensor. Now, why there is a importance of a sensor in automation? As I earlier said, in an IoT, suppose if you want to make your system automatic, if you want to make your system smart, at that time sensor is need. Why that is sensor is need? See here, the sensor in automation has same importance which sensory organs have for the human being. Yes, guys. As if I said, close your eyes, close your ears, and just cross the road, is it possible to cross the road? So definitely it is possible, but there will be definitely chances of accident. So in our body, like our organs, like sensory organs, the same role is played by the sensor in the automation. Here we can say man is replaced, but not function done by the man. Sensory organs replaced by the various type of sensor. You can see here the eyes, nose, ear, all these sensory organ are replaced by the sensor. And now our role as a technical person, as a faculty, to use this sensor for our application. These sensors are readily or easily available in the market. So sensor, what is the function? Sensor communicate to the controller what is happening in the process being controlled. More accurate is sensor information, better is process controlled. Based on the sensory information, controller can take the decision as per the programmed logic and actuates the different output for accurate and precise control. Sensors conveys the information in terms of voltage or current or pulses, which is controller easily understands. So now it is as a technical person, how we can use this sensor. For making the use of this sensor, there are two type of sensor mainly. First one is the digital sensor, or I can say the types of sensor outputs. First one is the digital signal, and next one is the analog signal. Now, digital signal is potential free output. It having the electronic switching output. I have explained here what is mean by potential free output. You can see here in this diagram, this is the physical or analog input signal. It may be a pressure, it may be a temperature, it may be a position, it may be a flow. This data is gathered by the input part, and this data is converted or converted into electromechanical form, that is digital output signal, potential free output outputs, and there are three potential free output here: NO, NC, and CU. Now see here how exactly it works. Here we can see, and if you talk about the analog signal, there are two type of analog signal, that is voltage output, and next one is the current. In voltage output, you will get the output in the form of 0 to 10 volt DC. And if your sensor is giving the output in the form of current, you will get in 0 to 20 milliamps DC or 4 to 20 milliamps DC supply. Now, here we can see in this diagram, I try to show you here how exactly this pressure, temperature, or humidity, this data got converted into the electrical signal. See here, I have mentioned here, this is analog signal for pressure DC, and there is a direct relationship. Here, I have mentioned here, this is V minimum, and this is phi maximum. It means that it is giving the output. This is in 0 to 10 volt form. It means that if we take the example of pressure here, if the pressure is 0 bar at that time, the output voltage will be the 0 volt. And once this pressure is increasing from maximum value is, suppose we will consider, for instance, 100 bar. When this value get converted from or getting increased from 0 to 100 bar, at that time you will get the output of sensor in 0 to 10 volt form. It means that for 0 bar pressure, you will get the 0 volt. For 100 bar pressure, you will get the 10 volt. So, this is the direct relationship of pressure. In the same way, if you consider the inverse relationship, in inverse relationship, V maximum, it means that here you will get the 100 bar. Suppose pressure is 100 bar, at that time you will see the 10 volt. And if the pressure is 0 bar, at that time you will get the 0 volt. In the same way, the above diagram shown about the voltage output. And below this diagram is shown the output for the current. You can see here, if the pressure is 0 bar, at that time, sensor will show the 4 minimum value. The sensor I have written here, used here, 4 to 20 milliamps sensor. It means that it is giving the output in the form of current. And current is minimum will be the 0 and maximum will be the 20. So for 0 bar, it will give the output 4 milliamps. And for 100 bar pressure, it will give the outputs the 20 milliamps. In the same way, vice versa, the inverse relationship I have shown here. Now see here, if I ask you guys, which sensor you will prefer, the voltage sensor you will prefer, or the current sensor you will prefer? Yes, if you so as I already told you, voltage output gives in the form of 0 to 10 volt DC, 0 to 5 volt DC, or 2 to 10 volt DC. And the current output will give the 0 to 20 milliamps, 4 to 20 milliamps in the form. Now, if I ask you which output type is preferred, current or voltage, at that time, your answer would be, guys, current output sensor you will prefer. Why? Because voltage gets dropped when transmitted over the long distances, which affects the accuracy of measurement. Voltage signals are more noise sensitive. So my suggestion is that, suppose if you want accurate output, suppose if you don't want, if the system is very sensitive, at that time we must prefer the sensor which provides the output in the current form. Okay. Now my second question, it's, suppose how 4 to 20 milliamps in a current form. I already shown you there are two sensors. One is the 4 which gives the output in the form of 4 to 20 milliamps, and second one is giving the output in the form of 0 to 20 milliamps. So which sensor you will prefer from out of these two sensor, 4 to 20 or 0 to 20? Now, for example, guys, I have tried to explain here with the help of one diagram. You can see here, for example, if I use the 0 to 20, 4 to 20 milliamps sensors out, at that time, if the pressure is 0 bar, at that time, it will shows the output 4 milliamps. And if the pressure is maximum, for example, that is 100 bar, at that time, it will show me the 20 milliamps. In the second situation, if I am using the 0 to 20 milliamp sensor, at that time, for 0 bar pressure, I will get the 0 milliamps, and for 100 bar pressure, I will get again maximum value, that is 20 milliamps. Now, in both the cases, in the first case, I am getting for 0, 4, and in the second case, I am getting for 0, 0. Now, guys, in case of any wire is broken, at that time, your 0 to 20 milliamp sensor, how will show the output? In this case, in this situation, if the wire is broken now, at that time it will show always 0 milliamp signal only. So you will not get the idea either temperature is 0 bar or the wire is broken. But in a second case, if you use the 4 to 20 milliamps sensor at that time, for 0 bar pressure, it will give us the 4 ampere, and for 100 bar, it will use the 20 milliamps. And if the wire is broken, at that time, it will show the 0 milliamps current. So that is the advantage for by using the 4 to 20 milliamps sensor. Now I have taken the example of one sensor or switch, we can say, that is pressure switch. Here I have shown in the diagram. You can see here, this is the contacts of sensor, that is NO and NC. If the temperature, here I explained about the pressure sensor or switch is a form of switch that closes an electrical contact when a certain set fluid, liquid or gas pressure has been reached a set point. Now see here, in the second situation, we can see here, if the set point is 60 bar, if the set point is 60 bar, at that time, how exactly pressure sensor will work? Once the 60 bar pressure will get, at that time, its contacts will get changed. It means that, for example, I want a system should be on when the 60 bar pressure I will achieve. At that time, the contacts of that, these contacts will get from will change from normally closed to normally open. Here I have shown with the help of one diagram. Here I am getting continuously pressure, and here I have shown, I have connected the sensor here, guys. I am getting here plus 24 volt as the sensor is DC sensor. And if I get here, I have shown, if I get the value of 30 bar, this is the set point. At that time, this contact will change. You can see in this diagram, once this 30 bar is achieved, at that time, see here, this contact got changed. Now, this valve is open. So, sensor works as per how exactly you are providing the set point to that particular sensor. We can see here in this diagram. I will try to explain this diagram here. You can see this is the pressure on y-axis, and here we can see the x-axis, and this is the set point you can consider here. Now, suppose for example, the set point is 30 bar. At that time, what will happen? See, in this graph, we can see till 30 bar, the contacts are connected to number 2 terminal. It means that, for example, this is the NC terminal. That is normally closed terminal. Now see here, once this 30 bar is crossed, at that time, your contacts are changed here. You can see here, from 2 to 4. It means that it changed from normally closed to normally open. Again, we can see here, once again, if the set point is crosses here, in this case, at that time, again the switch, the contacts is changed. So in this way, the sensor, I have taken a just example of pressure. So all the type of sensor, the working principle of all sensor is same. Now see here, with the dotted line, I have shown here one band, and that band is called as the hysteresis band, guys. Now you can see here on y-axis, I have taken the pressure, and here with the help of this dotted line, I have shown the hysteresis band. So what is meant by exactly hysteresis band? For example, if you set the 60 bar pressure, at that time what happens? When the pressure reaches to the 59 or 59.5, at that time the contacts of that sensor, or if you connected the relays, the relay or contacts of that sensor get shattered. It means that continuously on off you will see here, and it will hamper your overall system. That's the reason I have given the some hysteresis band. It means that we manually we need to set the band. For example, if the 60 bar pressure is there, for 59.5 to 60.5, I will set the hysteresis band. Till 59.5 to 60.5, it will not change the output. So it is necessary to set the hysteresis band in every sensor to avoid the shattering of that particular sensor. So hysteresis band is also known as the switch band or dead band, and it will avoid or it will save the chattering of the sensor. Yes. Now, next example, I have taken the proximity sensor. As I already told you, pressure, temperature, humidity, the working principle, the wiring is same for all the sensor. I have shown in the next diagram. Now, I have taken the example of the proximity sensor. We can see here, there are various type of proximity sensor, that is DC2 wire, DC3 wire, DC4 wire, AC2 wire. Now see here, suppose if you are using the DC2 wire sensor, at that time, you will connect the output. Actually, the color code is very important while taking or while using the sensor. Brown will show the positive, blue will show the negative, or we can say the 0 volt. If you want to connect the output, we'll connect to the brown part. If your sensor is you are using the DC2 wire sensor. And if you are using the DC, there are two types, polarized and non-polarized. Again, in a DC2 wire, and it is defined. Polarized means where we exactly connect the output, and non-polarized means where we exactly connect the output. Output means here I have taken the load in this diagram. Now, next one we can see here, I have taken the next example of sensor, that is 3-wire sensor, and which is mostly commonly used sensor, guys. Now, in industry or in agriculture automation, commonly used sensor is a 3-wire sensor. It having the 3 wires. The first wire is the brown wire, second wire is the blue wire, and the next one is black wire, that is the output wire. Suppose if you want to connect the output, we will connect the output to the black wire only. Now see here, again sensor is connected to the 4 types. There are mainly PNP-NO, PNP NC, NPN-NO, NPN-NC. And how we have divided this type, where exactly we will connect the output. For example, I want to connect, once the sensor will sense any presence of, for example, there is no moisture in the agriculture land, at that time the pump will get automatically on. At that time, I will connect the output, motor's output to this output black wire part. And with the help of this diagram, we can see how exactly we can connect the wire. There is the next one. It's a DC4 wire. In DC4 wire, brown wire, positive, blue wire will be the negative, black wire. There will be the two output, that is black wire and white wire. Again, TC two wire system. Now, one more device is used in the automation, agriculture automation, particularly timer. Actually, timer is readily, easily available in the PLC, but your system is very small system. You don't want to use the very you don't have a more land. For example, for 50 acres or 100 acre, and there is only 5 acres or 2 acres or 3 acres land is there. You want to implement the automation in our system. For example, we can say, for if you want to on the automatic pump on or off purpose. At that time, this timer will play a very important role. Timer counts the time. It is a one type of relay, we can say, or we can say time delays relays. In automation, timer used for the counting the predetermined time delay for time dependent activity. I have taken the timer consists of mainly a coil, relay contacts, and power supply. Now see here in this diagram, I have taken one switch, and suppose this is your pump, consider for a minute. And when we on the switch, at that time, we want to on this pump after a minute. At that time, you can use this timer. When I on this switch, see here what will happen. The switch gets closed after the time which is predetermined or which is set by you. This output will change. In the next diagram I have shown here. So see here, there are different modes of timer: on delay mode, interval mode, off delay, and cycle. For example, on delay mode work will like this here. Suppose this is the S1 switch. I have used timer here. When I activate this S1 at that, see here, after the 5 second, this lamp will go. You can see here in this automation. See here, I have on the switch. After the 5 second, this motor or this output will get. Likewise, your timer will work here. Here in this waveform also I have shown here. See here, I on the timer. After, see here, this after the delay time, your pump, your motor, or your output gets on. So what are the, I have shown here, you will find different modes according to your use. We can use this mode which is available in hardware timer. That is on delay, interval, power on, flasher, cyclic. You can use as per your need. And the next part, which is very important for making your system automatic, that is PLC. That is programmable logic controller. It is a special computer, we can say, used for the industrial control system. It provides the flexible way to software the different components together. And I can say the word programmable in a PLC differentiate it from the conventional hardwire, I am saying. Hardwire relay logic. See here, what is the meaning of software? I have tried to explain here. I have taken one switch and one lamp is there. Now, if I on this switch, the lamp will get on. And if I off this switch, definitely the lamp will get off. Now, for example, I want to use the two switches, and one switch is installed at the ground floor and another switch is installed at the first floor. And if I want to make this system, suppose by using both the switches, I want to on or off this lamp, what I need to do? I need to dismantle the previous connection. I need to make again one more time connection. In a second situation, for example, if I want to on this lamp, when I on the switch, after the 10 minutes, I want to on this lamp. Again, what I need to do? Again, what I need to do? Again, dismantle the connection. Again, making the connection. But if you are using the PLC, at that time, there is no need to make the change in your connection. You will make the change in your program only. That's why PLC is called as the software system. Now see here how exactly PLC works. This is the input side, main PLC, and that one is the output side. It performs the relay switching task, counts, calculation, comparison, analog process value. Analog means temperature, pressure, humidity, etc. Offer flexibility to modify the control logic by only changing the program. Respond to change on a process value within the fraction of second. Easy and quick troubleshooting. Improve the overall reliability of control system. Cost-effective solution for complex problem. And as I already showed, this is the already said this is a mini computer. So the architecture diagram of the PLC is the same like a computer. On a left hand side, input will be there. On the right hand side, output will be there. CPU, memory, program data, power supply. The next diagram I have shown here, how exactly the input part we can connect and output part we can connect. Now see here, this is the classification of PLC. Suppose if you are a very small farmer and if you want to implement the automation in the agriculture land, at that time we want to purchase the PLC. How we can purchase? So definitely the small farmer will consider the cost of the PLC. The PLC mainly consists of the number of inputs and outputs, cost, physical size. Here, I have shown here, suppose there is a micro PLC, you will get the 32 input and output. If you are using the small PLC, you will get the 64 IOs. IOs mean input and out. If you are using the medium PLC, large PLC, very large PLC, as per your requirement, you can choose the PLC. And main important thing, the cost of the PLC is depends on the how many IOs are available in the PLC. Now see here, how exactly CPU of the system will work. First of all, it will detect the information, which inputs you have connected. And according to the program made by you or made by engineer, I can say, the it will processor will execute the program, and according to the program, you will get the output here. So this is a very simple working style of the PLC. Even any electrician who having a quite knowledge about the PLC and program, he can easily work on the PLC system. Why I am telling this? Because we want to implement this system for the agriculture land. In that way, I am telling the PLC we can use. There is one concept that is scan cycle of the PLC. How exactly PLC scan the program? First of all, it reads the input, and it run the program and adjust the output according to program. This is the scan timing, which is I have already explained. These are the input IOs we can say, that is input and output of the PLC. That is discrete time. Mainly IOs is divided into two types. That is discrete type and analog type. In a discrete, it means that digital. IOs we can connect the push button, switches, limited switch, proximity sensor, photo sensor, contactor, relays, lamps, alarm, shooter, LED. And these all components you need to just as I already told you the how to do the connection of the sensor. In the same way, switch, their switch consists of NO and NC buttons. Easily we can connect this switches, sensor to the PLC if you have the basic electrical and electronics knowledge. In the analog parts, suppose RTD, if you want to measure the temperature, you need a RTD sensor, thermocouple, or thermistor, we can say. According to your need, we can use connect the iodes. This is the simple diagram. In this diagram, I have shown how to connect the iodes or input, particularly to the input module of the PLC. And this is the program of the PLC. Now let's see here, as if you are coming from the engineering background, guys, if you know the basic electrical relay logic, you will easily understood, you will easily do the programming of the PLC. So what is mean by programming? It is a set of instruction user writes to tell the PLC what logic to be executed. Execution of program depends on the status of devices connect to the IO modules. And mainly in our country, or we can say mainly in many countries, ladder logic is most commonly used PLC programming language, and which is used to write the PLC program. This is a very simple example, guys, I have taken. See here, this is the ladder logic programming of the PLC. In this, why this programming is called as a ladder logic? You can see the structure of the programming is like a ladder. That's the reason such type of PLC is called as the ladder logic. Here we can see uh, there is a input NO and NC, and at output side there is a coil, we can say. And in PLC program you will find only NO, NC and coil, nothing else. So once you understood the relay logic or electrical diagram, you can easily do the programming of the PLC. There is another programming language, FBD, that is functional block diagram, which is used for the making the PLC program. And those people having the more experience, these people uses the FBD or STL programming language, which is quite similar to the C language. Easily those people having a more command on C language, such type of peoples use the STL programming language. This is the simple example of the PLC programming language. On the left hand side, this is called as power rail. This middle part is called as rung, and these are the instructions. That is NO instruction, NC instruction. Left hand side you will find the input part, and right hand side you will find the output part. Now will ask me how we can use this PLC for the agriculture. So I already done many use cases where exactly the PLC or how exactly PLC can be work for the agriculture automation. You can see here, suppose if you want to do the irrigation system in a many foreign countries, I have taken the example of Netherlands. All their farm agriculture land is based on the PLC. They are doing the irrigation by using the PLC. What PLC automatically takes the data, soil, measure the moisture of the soil, weather forecast, crop requirement. It takes the data, gives the PLC, and according to the PLC, the program will learn, pump will be on, pesticide will be will sprinkled by the automatically system. Next one is the greenhouse climate control. We can say PLC monitor and control temperature,
Hello. Sir, there is no audio. Please check.
Am I audible, sir?
Yes, sir, you
Okay.
are proceed.
Sorry, sir. Actually, there was a technical glitch from my side. I extremely sorry for that. So I already explained about the hydroponics and aquaponics. Nowadays in urban area, there is a huge demand of hydroponic farming nowadays. Everyone is using the hydroponic farming. Okay. So in this area, we can use the PLC directly. Now see here, next one is the system is a SCADA system. And that is the very hot topic of nowadays in a industry or in a agriculture land, we can say. Suppose if you want a graphical representation of your system, if you want to see the how exactly your crop or how we can monitor the system, we can use the SCADA system. SCADA is supervisory control and data acquisition. Okay. So here we can see the SCADA is a system software and hardware elements allows the industrial organization to control the industrial processes locally or remotely, we can say. It monitors, gathers, and processes the real-time data, directly interact with the devices such as a sensor, valves, motors, and more through the human-machine interface software, and it records the event into the log file. So if you observe, the sensors, valves, motors, temperature are all related to agriculture. So there is a huge scope of SCADA in agriculture automation, I can say. See here, I have taken one example here. You can see, suppose if you want, suppose this is the one graphical representation. There is one chemical plant, and I have shown the graphical representation of chemical plant. In the same way, you can draw, you can give the graphical represent exact graphical representation of your agriculture land. You will see how exactly the different parameters are working, how exactly the soil is getting a minimum temperature, moisture, or how the health of your crop is there. We can easily maintain. So the basic SCADA is programmed with the help of PLC or RTOs, we can say. This is the features of SCADA, that is dynamic process graphics, alarm handling, real-time trends, historical time trend, and security. I will explain very few of them. Uh, for example, I am taking the example of real-time trend. In the last year, how much temperature was expected to grow this crop? And for example, there is a change in the environment in the next year. In real time trend, guys, you will see how exactly temperature is essential for this particular plant, and how should I maintain. So if you already installed different sensor now, it will work work you will give it will give exact graphical representation in the form of chart, I will say, to observe or to monitor what was last year the condition of this crop, what was the last year temperature, what was the last year humidity, and how much I should maintain this year. So this is the one example, that is real time trend, or we can say the historical time trend. Such type of very basic, very common, or I can very important things you will get with the help of this such type of trends, we can say. Recipe management is there. Recipe management, it means that, for example, uh, if you want to give, suppose if there are two crops, suppose bajra crop is there and suppose wheat crop is there. And for wheat, you need to give the irrigation after 10 days. And for example, for bajra or cotton, you need to give the irrigation after 15 days. And such type of recipes we can program in your SCADA system. And once you program that recipes now, you will easily, it will irrigate the water to that particular crop, I can say. So in this way, we can use the SCADA system. And what are the different ways to interface the SCADA with your controller? So definitely, as I have shown here in this diagram, there are different sensors and controller. They can easily configure to the PLC RTO, and based on your PLC program, you can give the tags to the SCADA. And what is mean by tag? So in a PLC program or any other program, you must have seen the instructions. So in SCADA, instruction is replaced by a tag. As an instructor, you can use the tag here. See, so these are the, I can show here. So see, this is the screen. Suppose if you want, this is the one example I have taken. For example, you are doing the smart agriculture. If you want to use the smart pumping system, you will use the one start button here. One you will use the stop push button here. You will use the motor symbol here there. And if your agriculture land is far away from your residing place, from your home, you can on your pump, you can off your pump. You will see here the pump is getting on or not, as SCADA is provides the graphical representation. You can see here. So how exactly the SCADA used in agriculture? you can use for irrigation management, greenhouse management, water and fertilizer distribution, farm equipment automation, livestock monitoring, data logging, and reporting. You can use the SCADA. And next system is HMI system. And HMI, there is a no difference between SCADA and HMI. Just SCADA is a software we can monitor from your computer, and HMI is the system you can carry with your machines, I can say. So HMI play a very important role in automation. And next part is the AC drive. And AC drive is the variable frequency drive. I can say in maybe AC VFD play a very crucial role in automation. So in suppose I can say here the VFD we can use for the main function of the VFD is to control the speed of the induction motor. Main function. I have, and other than function, we can use the for if you don't want to use the starter for start stop purpose, for protection system, pre magnetizing, for skip frequency, you can use the VFD. This is a very simple device which is looking like this. You can yes. So 1 second. So you can use the drive. This is the block diagram of drive. Drive works. It exactly means control the speed of the induction motor. Drive having the different name in a different region. We can say AC drive, VFD, VSD, AFD, ASD. So these are the some applications of drive. These are the working of drive. And if you ask me what are the challenges and limitation of the automation, I can say the definitely as our farmer are having the problem of many times we see because of the cost they cannot implement the accurate automation. But as we can see in a coming 10 years, as our we are the populated country, so we need automation. So we don't have any option uh, without implementing the automation in our agriculture. We can say the complexity technology, resistance to change, data privacy concern, job displacement, environmental impact. These are the challenges. And nowadays we can see these are the future trends, that is advancement in technology, precision farming, blockchain, supply chain. And these are the some impact of automation, increase the productivity, reduce the labor cost, job displacement, replacement, enhancement, compute needs. And if you implement the automation, you will increase the productivity, 50% reduction in the cost, and 30% in the saving of water, I can say. So thank you so much. Actually, because of the time concern or technical glitch, I cannot explain the VFD properly, but I will provide the some way of this part to the co-coordinator of Dr. Praveen Wankade. If you want, you can discuss with him. You can take the PPTs or you can take the part of VFD from him, or I am available. You can take my email ID from him, or we will have the discussion on the same. Thank you from my side. Thank you, sir.
Thank you very much, sir. Thank you, sir. Now, you have given a wonderful session on how different automation parts are there that you can use in automation for the agriculture. For the participants, if you have any questions regarding the today's session or the today's topic, you can ask the expert. I request participants, if you have any questions, you can ask the, they can unmute themselves and they can directly ask. Okay, sir. Hope so. We don't have any questions. So what are the different questions will be have there in the chat box? I will collect them. I will try to share with you so that whatever your answers will be, we will forward them to the participants.
Sure, sir. Thank you so much. Thank you.
Thank you, sir. Thank you.
Yes.
So now we'll move ahead with the next session. So today we have the another session by Mr. Chaitanya Gori, software developer at Zensac at the Sweden. The topic is the ADAS for the farming. So I just want to introduce him. Mr. Chaitanya is a bachelor in uh, engineering of electronics and telecom. He has completed his master's uh, in automation systems from the University of Côte France, and also he has completed his Masters of Science in Intelligent Automation Systems from KTH Royal Institute of Technology. Uh, uh, he has started his own startup uh, with the CMS, and also he worked with the KUKA Robotics as a robotics application, and now presently working as a software developer with ADAS with the company Zensac at the Sweden. So, giving his expertise, I request Mr. Chaitanya to start with session.
Thank you for the introduction, Praveen Vankade sir. And soon I'll present you with ADAS technology. So before going into the depth, I would like to tell you what I do, and then we'll go more into detail of how autonomous vehicles are there, and then how we can find their use cases in the farming technology. So I will share the screen now. Um, can you confirm if the screen is visible?
Yes, it is visible.
Okay, great. So as Vankade sir introduced that I work as a software developer at Zensact, and I'll introduce a little bit what we do at Zensact. So as per the statistics and data, it has found that there has been 1.2 million deaths every year worldwide, which is a quite number. And it has been seen that most of the accidents are happening because of the human errors and because of lack of the automation in the vehicles. And it also has observed that there has been 50 million plus million injuries worldwide. So we think the automation is the answer to solve this problem, and it will be reduced. So that's why we want to become a world leading software technology company for autonomous driving. And here at Zensact, we have a goal of towards zero faster, which means we want to have a zero accident with the product produced by our company. At Zensact, we are 800 plus employees. We have 100 plus deep learning engineers. We have 150 perception expert and more than 20 researchers. We have offered 10 plus world class active safety software uh, to, uh, to our parent company, Volvo Cars. We are located in Gothenburg, in Sweden, where our headquarters is, And we also have our offices in Germany and China. We are very closely located at a strategic location in Lindholmen Science Park, where we closely collaborate with other companies, for example, AI Sweden, Ericsson, NVIDIA, and we closely work to solve the problem of autonomous driving. Currently, our softwares are in Volvos and Polestar cars, and these cars on the road and saving millions of lives. If you know that Volvo is considered as one of the most safest car in the world, and we are so proud to say this. Yesterday, the Volvos were old-fashioned. These days, we have a lot of so yesterday we had airbags and safety belts and lot of passive safety passive safety things, like for example, if accident happens and there has been some take cares were taken, like after happening of accident, okay, then there was a blowing of airbag, and the seat belt was helping you to not move within the car and saving you. But what we want today is what we can do to avoid accident, not act after the accident has happened. And this is what we are doing today. And who knows what we want to bring tomorrow. We want to have the best in the world class safety software. So that's Zensept. Uh, so now I will jump into my main presentation for today, where I'll talk mostly about autonomous vehicles and followed by some case studies in how the autonomous vehicles will be used in the farming industry. Uh, my presentation is lacking a bit. I'll wait for a few seconds to load it. Okay, yeah. So what we will go through today. So we will have an overview of whole autonomous car or autonomous vehicle, then description of different sensors which can be used. And then I'll explain you what perception is and how these different sensors can be used to extract different information in the surrounding. Then I'll explain you about SLAM, which is called simultaneous localization and mapping. So it localizes where the vehicle is and creates a map of the surrounding. So we can plan the trajectories or the movement of vehicle in the specific environment. For example, if we have some hectare of land, and then with the SLAM, we will able to localize how big is the farm and where are the different trees. And then after that, I'll explain you the navigation, how the vehicle will move within the farm or on the roads for the cars, and then the software development for these kind of vehicles. Then I'll go through some case studies of autonomous driving in farming industry. And in the end, or while I'm talking, you are feel free to write question in the chat. And in the end, you can unmute yourself and ask us question. And I'll try to answer to the best of my knowledge. So what a car or an autonomous vehicle can have. So most of the things usually, so if you consider on an overall level, every autonomous system has some main specific components, and which can be electric motors, or we can call it actuator, which will help you to move the vehicle or to perform some specific action. Then we'll have some power electronic controllers to control the motor, some converters which will convert energy from DC to DC or DC to AC or vice versa, some thermal system uh, to cool down the power electronics, and some transmission. Then we'll have a power source, which is battery. And for the specific on, if we talk about the car, then we can have onboard charger and charging port and traction of battery pack. But as I want you to consider, like sometimes I will have more images in terms of car, but those will be pretty much similar to the any robot in the industry. Vehicle uses and challenges these days. So why we need a vehicle uh, or an autonomous vehicle? The simple reason is that when we want to move from point A to B, for example, you want to travel, and for that purpose, we need a vehicle. And what extra things we want from the vehicle? We we want it should be interactive, so that everything in the vehicle is controllable as per your command. It should be personalized as per your need. You should able to use it. It should be connected to your phone or your smart devices, watches you can use. You should have some fun, audio and ambience light in the vehicle. You can also think of vehicle should have home extension. So these are some things you want in a vehicle. So here I have listed a few questions about ADAS, which is Advanced Driving Assistive System, and autonomous driving vehicles. So what is ADAS or what is AD? So these are some questions I will just read and try to answer all of these questions in my presentation. What is autonomous driving vehicle is, where autonomous driving vehicle is running, what does ADAS or AD technology bring, what is needed to make self-driving vehicle, what are the hands of eye of mind of technologies that I will explain you with the case study, what are the differences between autonomous driving and robot taxi or just robots, why autonomous driving vehicle or taxi are not deployed today, and we will try to see how these are deployed in the farming industry. Here I have listed some things which AD ADAS technology brings. So the AD ADAS technology makes roads safer with the different kind of features. For example, if you have seen autonomous emergency braking, um, in this feature, autonomous emergency braking, if any object comes in front of the car, then car automatically detects the object and it applies brake even though the driver is not in the attention. So these kind of features are making roads safer. It can also make driving more enjoyable. Um, and also we have seen that like humans, they cannot drive for long. Sometimes we have seen that a lot of accidents have happened because of the dizziness, or driver has drove for quite long and he feels sleepy and lose the control of vehicle. So these kind of autonomous driving technology can be helpful in public transport, and it can operate 7 days a week and 24 hours every day. So also when this technology will be implemented, you can delegate driving to make other tasks. So for example, you can focus on your work, you can read, or you can even sleep in the vehicle because everything will be taken care by the software in the car. It can also help you to reduce the carbon emission or the CO2 emission, which is done by the car. For example, when human drives a car, it's uh, we I mean we try to drive with the economic zone, which should not produce so much CO2. But with the AI algorithm and some software analysis and the data point, it can monitor the engine and try to allocate specific speed, and with the specific acceleration, it will reduce the CO2 emission. It can increase the efficiency uh, for example, at airport, the autonomous vehicles are used these days to pick up your bag and drop it to the plane and vice versa. So this can also reduce the, if the roads are more safe, then it can reduce the number of deaths and accident. That is the main objective for the autonomous vehicle. And as I said earlier, it can also bring a power efficiency. So how autonomous vehicle looks the surrounding. So there can be a different crossing path and different scenarios where we need to operate this vehicle, and autonomous vehicle should understand its surrounding before taking an action. So this is just an example of one square in a city where there are multiple lanes, some there is also bridge, and this all information has to be taken care by the autonomous vehicle. So we will see how all this information has been pursued by an autonomous vehicle, and later how it has been used to make a decision and have a final target to achieve our autonomous driving. So there can be a different kind of ADAS technologies, or so where we have a simple vehicle where there is no automation, just a driver is taking control of entire vehicle. Then there can be some driver assistive features where for some specific duration, the car can give you suggestions. For example, when you are driving in a specific lane but the another lane is empty, then your vehicle can suggest you, okay, the another lane is empty and you can drive faster in that lane. So you get some assistance and you use the assistance to change your driving skills. And there can be, then next level is there can be a partial automation, which will bring you, you can leave your hands, and when you are on a straight road where the car will operate by itself, but it cannot take complex turns. So then there it comes a fourth level of automation, which called conditional automation. Then in the fourth level, it will monitor the surrounding and look into the different paths where you have set to go, and based on that, it will take a specific turn. With the last level of automation, or we call it high automation, in this one, you don't need to make anything. You just set on your phone that you want to go to A to B, for example, any city. for example, Mumbai to Pune. You just set this and you just sit in the car and the car will bring you from A to B. And that will be a high level of automation. So what needs to be done? So there can be a lot of things need to be done, and which will be, first thing is like how we can see the surrounding. So this is a one high level block which shows how any automation or any autonomous car can have. So first we need to detect the surrounding, the objects around the car, other vehicle, trucks, bicycles, motorbikes, trees, different lanes. In the farming industry, lot of, for example, how you have cropped, or how are the farming has done, how the crops are there in the farm, how is the shape of the farm, and then understand everything in the surrounding and make a decision based on this, like what action we need to take, and in the end to act on it. If you want to make a bit zoom into this block, so it will be like this. So we'll use different sensor to see the surrounding, uh, which is then we will have some perception algorithm. We call it environmental model. Based on sensor input, uh, your autonomous vehicle can decide what are the things around it. So it can be done with artificial intelligence or deep learning. And based on the information you have, then the decision will be taken with the help of actuators. So what are the different sensors those can be used to monitor the surrounding? So we can use LiDAR sensor, which will be create rotating cloud points. It will monitor the entire surrounding. I'll show you how LiDAR point cloud will look like. We can also use the GPS to monitor the location, but GPS is not super accurate. We can use the cameras to monitor the surrounding, different kind of ultrasound sensors. We can have an odometer to measure how much the robot or the vehicle has moved. If we are good, we can use the HD maps. So HD maps this is a service which you can take it from Google or any other map provider, which gives you the satellite imagery for your farm or um, anywhere you want to use your robot or autonomous vehicle. Then there can be also some radars which can be used to find the objects around, and you can have some inertial measurement unit, which is called IMU, which will give you car acceleration, angular velocity. So these are the sensors we can use. There can be more sensors than what I have listed here, but I have listed the most of those available and used these days in the autonomous vehicles. So what is LiDAR? So LiDAR is a sensor which monitors entire surrounding in 360 degrees. So the specific LiDAR I am talking here, it is having 32 beams, and it continuously rotate and monitors the surrounding for the specific every millisecond or microseconds, depends on the availability of your computing power. But over here, this LiDAR it has 100 hertz frequency, so it makes 100 rotation by every second. And these LiDAR are used mostly in the farming or in autonomous vehicle to find things around the vehicle. So with the LiDAR, if you have run this algorithm, look at the image in the right. For example, this is the this image from the camera, and how the LiDAR point cloud will look like, which is an example in the left. So the LiDAR we can, with the LiDAR, it will detect the environment around the vehicle. So if you can see, here are three cars in a line. So these three cars, if you can see here, these are the three cars, and there are three more cars in the front. So these are the three more cars in the front. So with the LiDAR point cloud, you will able to detect what is there in the surrounding. And if you can see, there are some trees here, these two trees, and some bushes on the left. So these trees are also detected by LiDAR. If you see over here where my cursor is, on the left hand side, if you see the bushes, it has detected the bushes, and also the building in the left. So we can use LiDAR not only in urban areas, but to detect things in farms. To get a good result, we need to do a sensor calibration. So there are different cameras which we can have in autonomous vehicle, which will usually there are more than 7 cameras these days used in autonomous vehicle. So there are some front cameras, there are some cameras on the both side of the mirror, and cameras in behind, and there is fisheye cameras which sees 360 degrees, and there are some cameras which just look into 180 degrees. So my point of consideration here, we need to calibrate every sensor to get a good results, to get good efficiency of the vehicle. Then there is ultrasound sensor, which uses the concept uh, of ultrasonic. It emits a short range of ultrasound, and where are the objects, it reflects back from it, and based on that, it finds how far the object is. And but it there can be a different ranges of ultrasound sensors which can be used, but it is mostly used in the closer targets. In general, it is used more than 30 centimeter distance. But when we detect the objects in surrounding, there can be a different things. Sometimes a sensor can detect something which is actually not there because of the glitch, or for example, the sensor is covered with something, or there is a dust, and there can be a chances that there is something which sensor cannot detect also, and there is also a chance that there is nothing, but sensor shows that there is something. So these kind of problems are called false positives and false negatives. And these problems has also to be taken into consideration in the autonomous or vehicles or advanced drive assist features when you implement in a vehicle. And there are different kind of algorithms which can be used to uh, control false positive detection and false negative detection. So how the main block will look like now? If you remember, we had very limited blocks in the start, and now I am zooming in more and more, and now we have sensors which you have learned, which is, it can be cameras, LiDAR, radar, GPS RTKs, ultrasound, or context cameras. Then these sensors will be used in the perception, and with this perception we can do a localization. The localization sensors can be GPS or GPS RTKs, and this information will be used in the decision navigation path planning, uh, which will help you to move the actuators, and we can take a decision based on it. So if I zoom in to these blocks in more details, so how it will look like. So as I have discussed everything here in the sensor part, so with the perception, we will able to detect objects around the vehicle. We can do a fusion of different objects. For example, uh, cameras can be good when there is a sun, but in the night the camera can be bad. But in that case, then LiDAR or radar can be good in the night operation. But in the sometimes in the rainy season, maybe then LiDAR or any other sensors will not work so well. So what we want to do from this, we want to have fusion of all the sensors. So if we use all the sensors together and have an interlock of everything together, then we can have a better decision algorithm which we can use to detect obstacles around or the objects around. Along with these, we can use the map services on the cloud, and which will help us to move the vehicle. So how we can move the vehicle? We can have a steering. We can have steering motor, which will use to steer the robot or the steer the vehicle. Then we can have brake. Whenever it is necessary, we should able to stop the vehicle based on the need. If it's light, we should able to turn on the lights. We should able to horn if there is a object in front of the vehicle. We should able to turn on the wipers when it's raining, and we should able to give a warning light if a car is parked on the side of the road. So this is like a main block which are usually there in any ADAS vehicle. So here I have listed some obstacles or objects around the vehicle which are normally seen on the road. But in case of the autonomous agriculture robot, this can vary. There can be bushes and some animals, mostly, or maybe in some farms, there are electric poles and there are crops and there are big trees. So these all things can be detected. But in terms of the car, we have different kind of objects. For example, as I said earlier, there can be a car around, there can be trucks, bus, two-wheelers. When you are in a forest, some animal can pass the street. There can be some construction site. There they have barricades or some lot of things happening. There can be some things which are not known, or for example, there is something on the street which is we haven't classified, so we can just call it some small unknown, and if there is quite big something, for example, if someone has kept something big or like a box of cartoon on the street, then we can call it unknown big. And with all our sensor and the decision algorithm, we will able to detect and annotate the objects which which are around the autonomous vehicle. So based on the sensor detection and the algorithm implemented, we will able to check and annotate that, oh, this is truck, this is car, this is car. So here is a one slide I bring, which is very important into the consideration, that cyber security of the vehicle uh, or the robot. So these kind of things has to be, it has been observed that from one case study that the Jeep Cherokee was hacked in 2015 by some unknown, and it started blinking all the lights in the vehicle. It started playing music very loudly, and it started rotating steering on either side. So everything was not in control for the driver who was there. And then later it has been found that it was an cyber attack on the car. So these kind of cyber attacks can happen on any autonomous vehicle, whether it can be on the street or on the farm. So when we develop this algorithm, so we need to take care of cybersecurity and how unhackable our system or our vehicle is. There are some challenges, some things which are not uh, easily detected. For example, if the car is entering a tunnel and it suddenly gets from light to dark, and then in those situation it will be quite hard to detect the sign and what is the information given on it. So these are some challenges into the autonomous car industry, but that cannot be the case for the autonomous farming industry. So now I'll give you a bit detailed example of how autonomous car or an autonomous vehicle should work. So as I have explained you an bit overview of how the system will look like. So here I am considering only two sensor in this example, where we have LiDAR point clouds and camera images, which is a perception. And there are cones on the street. I'll show you in the next image. Based, based on that, we are doing a simultaneous localization and mapping. We have some motion sensors, which gives us the location of the car, how much the car wheel has moved. Based on that, we create a map and vehicle state, and we will navigate the vehicle with the steering and torque in the motor. So this is an one example which I want to discuss with you. So here we have sensor. So the upper one is the camera image and lower one is the LiDAR point cloud. And if you can see, this is an path where we have a different cones. And these cones are colored blue and yellow. So usually the blue ones are on the left, and the yellow ones we have kept on the right. And this is the study we have done in 2022, where we want now this vehicle should pass through this path with the algorithm we have developed. So from the camera image, we put some algorithm which detects the cone, and it start detecting all the cones. If you can see, now it has created the bounding boxes around every cone. And then this information we get from camera, and then we get point clouds from LiDAR, and then this is a raw point cloud, and then we have processed it, and then we were able to detect all the cones. If you can see it, it looks a bit darker. And then we have when we merge these both things together, then we can have more robust input, which we can use to make a decision. And that is called sensor fusion. So here I have some more detail, like what image has, and we are using YOLO V4 model for the good accuracy, and we have kind of fast interface up to 30 to 40 frames per second, compared to the YOLO V3, which has 7 to around 7 frames per second processing. So that's why we use YOLO V4 here. That's I wanted to say. And if people who doesn't know what YOLO is, it's a model used for the detection in the images. We have in the LiDAR, we have used some point clouds. So point clouds, if you can see this image here, we have cones again. So these every point is called a point, and this all information together is called point cloud. And in this image, you can see the poles, and you can also see the things around, some of the things. So usually what we do in this, we apply some filtering on this. So we remove the ground. For that, we use the Euclidean clustering method. And then we apply a clone cluster validation. So this is a cone. So there is a kind of information we get here. If you look, so we use a cone cluster validation, which detects just cones. So we merge this camera input and LiDAR input all together, which projects the clone cluster center on the camera frame. And it checks if the cluster is in the bounding box, which was generated before. If you remember over here, this bounding box, if the cone from the LiDAR, if it's matching over here, so then it is a double verification of the object in the surrounding. Yeah, and then we get a final cone with color. So with the LiDAR, we cannot find the color, but with the camera, we can find the color, and we can find the coordinates with the LiDAR. So that's why we are using different sensors together. And the camera calibration helps us in the 3D construction. And together we get, my image is not loading here. Okay. I will present again. Oh, sorry. Somehow it's not loading, so I'll show you like this. So here we had these images from the camera, and together we get, if you can see that, all the blue cones on the left and the yellow one on the right, and we have this mapped both. We have superimposed LiDAR point cloud and the image from the camera. So when we have this information, then we can think of localizing where our vehicle is in the surrounding and decide something on the mapping. So the goal of simultaneous localization and mapping is to estimate the pose of the vehicle and position of the all other landmarks on the track. So for the motion measurement, we as I said, explain you earlier, we can get a location of the vehicle by GPS, or by we can have some information from IMU, and we can also use how much vehicle has traveled by wheel encoder, and we get a steering angle or the steering information from the steering where the vehicle is moving, that we can find from the steering sensor. And we have done a landmark measurement from LiDAR and camera. This is one track where this we have done the experiment. It was in the association with the Formula student track, and where the university in Stockholm called KTH Royal Institute of Technology, where the students wanted to participate in a competition where the car has to uh, pass this hurdle or this challenge without without external control. So what SLAM pipeline key points are? So some pre-filter we can done by Kalman filter. What is Kalman filter? I'll explain you in next few slide. So what SLAM does is like it just find where the vehicle is and the surrounding and does the mapping of it. So that's it. SLAM is, and there can be a different method by which we can do a simultaneous localization and mapping. So then comes a part of navigation, because these are what I am trying to explain you, like what are the main components of autonomous driving. So there is a one perception, which can be done with the help of sensors. Then there is a simultaneous localization and mapping, where we will find where the vehicle is and what are the things in the surrounding. And then there is navigation. So how we can move from one point to point B. So the navigation can be done with the help of path planner. So we can, I will explain you how the path planner will work. And based on the path planner, we can have a longitudinal and lateral controller. So for example, the vehicle is moving in a direction. So if it has to go straight, it's longitudinal control. And if it has to change the lane, then it's lateral control. So the lateral control will give an output to the steering motor, and longitudinal control will give an output or information to the motor or engine of the vehicle. So how a path planning can be done? So as I explained you that we have a blue cones on the left and yellow cones on the right. So we can measure a distance of the cone, one cone to its nearest yellow cone, second nearest yellow cone, and third nearest yellow cone. And we can find a middle point between these two cones by doing mathematical calculation, by detecting first cone from the information we have extracted with the fused information of camera and LiDAR. Once we have this point in the middle, we can find that we can cluster the points all together. If we find 2 points, then we can just call it 1 point, and we can ignore the points those are not tracked. So this is called filter the waypoints, and then we can connect all the waypoints all together, and by this way we will get a path which will help the vehicle to pass through this path created by cones. Then we can apply some speed profiler. So determine, for example, there is a strong curve. So over there, we need to find like how much speed we should have, the curvature, the steering angle, and all this information. We need to decide that, okay, what is the friction of the surface, then whether we want to go in a straight line. If the vehicle is going in straight line, it can be faster. If we have more curvature, then vehicle will be slower. So this information we need to find, and based on that we have to find out the re- we have to find out the right decision we need to make. I don't know, my slides are not working super good in the full screen. So here you have an image where it shows there are the blue points on the left and yellow in the right, and then we have connected all the center points of all the distance measured between each middle point, and we have pointed it point number 24, point number 25, 26, 27, 28, 29, and we have connected all it together, and it has created a path, this green path, and which will be the path we will use for the navigation. So now when we have to navigate and for the vehicle, so then it comes like how we can navigate the vehicle for the and predict how the next path will be, because the sensors are mounted on the vehicle, and when we are moving on the path, it is not always possible to see the cones in the front. So for that, we can use some model predictive controls. It's called MPC, or a pure pursuit control. So these are the some different kind of controllers which can be used to find or to predict how the future of the path will be look like. So, for example, if you want to use any of it, then the pure pursuit is a simple controller. It's a steer towards a point at the reference path. It has no constraint into the consideration, and it takes more computational power. And then we have another MPC. It's called model predictive control. It uses the linear quadratic regulator problem formation. It's try to find an optimal control policy for the problem, and based on the vehicle model, the information we have from the different sensors, it optimizes the path, and it uses the normalization method. So we get some result. These are again not possible to see. Uh, I'm not. I wanted to show you these images. I will. I'll reshare my screen.
Mr. Chaitanya, actually, I think Dr. Patil has raised his hand.
Sorry, I cannot hear you well.
Uh, Mr. Dr. Nagaraj Patil actually raised his hand.
Okay.
Sir, do you want to ask something? Please unmute and you can ask your query if you have.
Yes, please. You can ask me anything if you have in mind. Okay, it seems my presentation is working back again. I try to change some things, so I'll share the things which were missing there. Can you see it? Can you
Yes,
confirm?
yes, yes, yes. It's okay.
Yeah. So this is how this point this model will find the center of both points, and based on the curvature and all, it will it will create a path for the vehicle where it should go, and then vehicle will follow this path, if you can see on the right. Yeah, so this one thing I wanted to show you, and the second thing I wanted to show you that this is just a model I have created, uh, where on the left hand side it's a pure pursuit type of model, and on the right hand side it's a model predictive control type of model. These are the different model which are used to predict the path, and you can see how they are detecting the center of the cone. I think the yellow will not be visible because it's super close to the white, and it's detecting the path. And if you can see in front of vehicle here, it predicts for 3 next point in front of the vehicle where the vehicle should go. So we get some enough time to plan vehicle motion uh, to follow the trajectory. So these are the some things I wanted to explain you here. Um, but now I will go more into the some use cases for how we can use this information in the farms. Uh, all these things you have learned from different uh, the different sensors and different models, and the things, those are very generalized for all the autonomous or ADAS vehicles. So it has been found that here I want to give in context why we are talking now and want to use this autonomous technology uh, in the farm or in the agriculture. So it has found that most of the population are moving towards cities, going to urban areas, and the farmers are facing a lot of challenges. For example, labor shortages, and there is a need of some sustainable practices. For example, use less carbon emission based fuels, and the new technologies, for example, autonomous driving, can be easily adopted in the farming, and which can help farmers. And there also one another thing that it has world has a population of 8 billions now, and it is expected to grow by 2 billions by 2050. So there is a huge need and the scope of using autonomous technology in the farm. So now we can see how it can be useful. So the market expectations shows that from the different studies that if we use autonomous equipments in the farming, uh, then we can increase the production the farm. It has been also observed that this technology can be used in the existing vehicle. For example, tractor, which is the most useful vehicle in the farms. So, for example, you can retrofit some cameras and some controller on the tractor, and it can help you. You can automate a lot of things by using it, and this will then if we use this autonomous extra features or retrofit on the existing equipments, then it can save some. It will be a bit cost effective for farmers. So the technologies which can be used in the autonomous agriculture can be like autonomous system and robotics, uh, uncrewed aerial vehicle, also called UAVs. Or there are some autonomous tractors are in the market currently, or also you can automize the tractor by using a different um, by using the methods I explain here. Uh, there is also a technique called precision agriculture where it monitors the crop, many different factors of the crops, and based on that, they make a decision. I'll explain you. I have separate slides for it. Intelligent robotics arm can be used to pick the robots and do the harvesting, and we can also have some autonomous UAV drones, not only um, which can also help to monitor farm and what are the different things around. For example, to monitor the cattles, where they are going, if they are entering into the farm, or if they are destroying the crops, that things can be monitored with drones. So first, what is a precision agriculture is? So precision agriculture is like where, for example, we need some kind of some specific moisture and nutrient contents in the farm. So these things will be measured by having different sensors in the farm, and which we can use this data and monitor how the farm is, how the crops are growing, and based on that we can create some metrics which can use to improve resource efficiency, and which will help us to yield more crop production. And also it will help, we don't need to put so much time in the monitoring the crops. uh, the artificial intelligence will play a good role in the autonomous vehicles in the farm, where robots mounted on a robotics arm mounted on autonomous vehicles can be useful to harvest uh, the different crops. It can use some image processing algorithms to detect different crops, and we can have some we can use these images and use create some key performance metrics for example, the tomato plant, it grows differently, but the potato plant grows differently. So with having a different images, and when it has given the best output or the good crops for the specific year or specific interval, we will able to save that data, and we will use this information for the next year and next year. And based on that, uh, in the early stages of the farming, based on how the crops are looking like, we will able to detect how the crop will look like for this year. And also there are a lot of different grass and weeds in the farm, and some plants are important and some are not. So by using by using robotic vehicle, we will able to detect which are the useful plants there and which are not. So for example, here the green detected things are the crops, and there are some other grass growing in this image I am showing, which is detected by a small red dots. So we don't need this red thing. So our autonomous vehicle can just pick this red part and keep the crop which we want in the farm. So this can Also, for example, if you have to spread the pesticides, it will only spread on the red dots and not on the main crops, and our main crop will grow. So with this all, there has been a standardization has done, which is implemented and called ISO 11786 uh, by the International Standard Organization, where there has some standardized protocol has been used, or they are introduced how it has been used in agriculture machineries. And this standard is also called ISO bus. I just added this slide so that you must know about the standardization, which can be useful. There are different navigation technologies which can be used to monitor your farm. As I said earlier, like total GPS view. Like if you see, sometimes it's possible to monitor your farm with the help of Google Map. But you have seen that usually you don't get a super clear image of your things you want to track. But there are companies, for example, John Deere and Tesla, they are bringing super ultra pixelated image, which you will able to track every day by the satellite for your farm, and you can collect all this data, which you can use to monitor and see the growth of the crop without visiting the farm. Here I have one case study where the John Deere is one of the well-known agriculture equipment manufacturer, which has created autonomous tractors, which has uses different cameras and advanced algorithm to navigate the tractor in the farm. I think we don't have so much time to go through the video, but I will just play a little part of the video. So I'll not go through this entire video, but I just wanted to show you that this there are some tractors in the market which are using ADAS feature, and they are already available to buy. There can be some more things which can be done to monitor health of cattle and their location, where they are moving, with the help of data tracking. Uh, and then there is, as I explained you earlier, there is a see and spray technology also implemented by John Deere, where they have one precise vehicle which uses computer vision to differentiate the wanted and unwanted plants, and only cut the plants which are unwanted, and or it cuts or it put a pesticides on it, and the pesticide overviews can be reduced by using this kind of technology. Yeah, it also makes the tracking. It uses some cameras. As I explained earlier, the unmanned aerial vehicles can be used to monitor the farms, and this can help you to minimize of the resources, and also it will help you to uh, reduce the use of chemical applications. And here I have another case study which is really good. I would say this robot has been implemented by NIA technology companies. It's also called TED robot. This one is used these days in the farming of grapes. So if you can see the image, it passes over the grape plant and it monitors the grape, and it also helps to harvest the grape. So here I have a little simulation how they have used it in their industry. So these are the plants row. If you know, the grapes are planted in a row like this, and here is the way how this vehicle is passing over and monitoring the grapes. The one below is the correct way where they have used the model predictive control, and the upper one is destroying the crops. So where they haven't used the good precision algorithms. So what benefits it can bring to the farming industry by having autonomous vehicle? So as per the sources which I have referenced here, we can there is a little use of or is a small study, and we have found that we get 4% crop 4% more crop production. It has been also observed that 7% more fertilizer replacement efficiency. It has observed that minus 9% overuse of pesticides. It has reduced the 6% of fossil fuel consumption. If you have a existing tractor and if you use the autonomous technology over it, it helps you to it helps you to reduce your fuel consumption, and also it has observed that it uses minus 4% water than now. But this data is not with the entire 100% automation in the farming. It's with a little changes in the farming. They have got this information. The article is linked here if you want to go through. This brings a lot of economic benefits. Using autonomous vehicle and the precision agriculture technologies can significantly enhance crop yields, improve the quality, and make the farming more sustainable and economically viable. However, there are some regulatory conditions; those needs to be fulfilled, and some approvals has to be taken. Yeah. So to conclude, overall, I think a combination of autonomy and precision agriculture with the help of AI, you can revolutionize the agriculture sector. It can address the labor shortages and sustainability challenges while increasing efficiency and productivity in the farm. That is all I wanted to say to you. And if you have some questions, please feel free to ask now.
Thank you, Chaitanya. Dear participants, I have given right all the participants to unmute themselves. So if you have any questions, please unmute the mic and ask the questions. You can also put your questions in the chat box so that we
Yeah.
can go through the questions and we can do the answers.
Yeah. I am trying to read if any question comes up in the chat. Uh, Please feel free to unmute yourself and raise any question if you want to discuss. Did you see any question, Praveen sir, in the chat which you want to ask, and I can try to answer?
I could not see any such questions there. Okay, so basically, just I want to ask one question to you.
Yes.
As you are there as a software developer with the Zenset, uh, we there are most of the people are from the academics here, those who are
Yeah.
listening to this session. So most and there are so many students actually pick up such type of projects for the farming.
Uh-huh.
So as a use of ADAS, what type of projects they can select?
For army application, do you mean?
No, 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 for the farming.
For the farming. Oh, yeah, sorry. Yeah. So, what I see is like our company is specialized only in autonomous vehicle or the autonomous cars, but I see every robot as the same. It's just an application. It's a different application. So sometimes it can be in the manufacturing, sometimes it can be in factory, or it can be on the street. So the best way, from my understanding, is they can look into the what challenge farmers are facing and try to solve that challenge by using existing technologies they have. Uh, so they can also go through the different use cases, which the use cases I have, I can try to share and go through those. And the one of the good challenge I have seen in which can be implemented in the India is there is labor shortage for the cotton picking, and some machines or uh, autonomous vehicles can be implemented to pick the cotton. That is one idea I have in my mind.
Okay, there is one question I think I don't need to ask. Which plant disease detection method is based at early stage?
Uh, can you repeat the question, please?
Which plant disease detection method is best at early stage?
Uh-huh. So you can have a different machine learning algorithms, or you, which plants. It's a bit hard for me to understand what they want to say. Can you reformulate that, please, again? Which latest method is used in early plant diseases? Aha. Okay, I saw the question now. So these days in the farming technology, what they are doing, they are collecting different images of the plants, and if they are keeping a track of it, in the end, if how the crop is it, if the crop is super good for that specific year, and then they monitor those images again for another specific interval of cropping cycle, and if they see some changes which are not matching with the when they got super healthy crops, then these changes in the images it helps them to find different diseases which can be produced, or it just gives an early warning that okay, the crops are looking bit different than usual, so we can think what disease, or like there is something wrong. And then It's more on the learning basis, uh, like the machine learning model works.
Okay. I think is there any question? So the same question was asked by Mr. Joshi, that is what type of research topics should be used pieces in the autonomous vehicles or the farming?
Stem using. Can you repeat? It's a bit hard to hear you, Praveen sir, for me at least. Can you please repeat the question? Or is it in chat again?
Yeah, it is now in chat again. So can ADAS system used in tractor for farming activities?
Yes, it will be used. As I shown you one video where the John Deere they have implemented ADAS systems. So what ADAS is? ADAS is like is a pre-version of autonomous driving. So in the ADAS, it's autonomous driving assistive features. So uh, we use ADAS name when the autonomous driving is not completely there. So when there is a collaboration of human and autonomous driving, then there are some features which helps. Okay, for example, if you are driving straight uh, in the farm, then you don't need to hold the steering. Then it will automatically uh, move the vehicle. So these or if you are cutting the crops, it will help you. Okay, where are the crops around the vehicle which you want to pick, and then it will point you to that direction. Okay, here are the one. If you have seen that sometimes there are blind spot. If you the people goes to pick the cotton and they forget some cottons because they cotton to pick because they are hidden by the eyes, but that cannot be hidden with lidar or other application which can be detected, and then it can point you that okay, something is left there, so you can go back and pick that specific fruit or specific thing you which is missing. If you have the strong algorithm written for use it in the specific detection of farming uh, the crop, I mean.
Yeah. Uh, just we'll take a last question and then we'll end this session. I just want to ask, as you have shown some of the case studies for the ADAS in farming,
Yes.
uh, most of these case studies are generally for the foreign farming cases are there. Just like in Indian scenarios, we have a lots of differences are there. So
Yes.
how could you suggest the different challenges will be there to
Yeah.
implement the ADAS?
Yeah, so it's a really good question, Praveen sir. And I have observed that in the foreign countries where one farmer has like 100+ hectare of land, and there they can easily buy these machines because they have a lot of things to do. But in India, it has been observed that sometimes a farmer has only 1 hectare or 2 hectare, and it is not sustainable for them to buy these expensive machines or implement those for this small land. So that's why it becomes bit cost ineffective for them to buy and use this kind of high or high cost machineries. So the one good solution is like they can use some small or cost effective methods instead of having big vehicles or most expensive vehicle. Or the one of the good suggestion which I have seen is like people, they use the machine, they buy machines altogether and use it just for the period when they want to harvest something or monitor it, and then they share the same machine with others, and they take the collective responsibility for the technologies they want to use in their farm. It has been done in some by some farmers in. Um, I may share the link if required.
Yeah. Okay. So thank you, Chaitanya. So it is
Thank you.
a wonderful session that most of the people now able to understand how the autonomous driving and the autonomous cars can work. Also, you have briefly given the idea how these ADAS can be used in different farming use cases. So I know that as you rightly pointed out, there are so many different challenges are there to implement in Indian scenarios to implement this autonomous driving. So there are lots of research uh, cases are there. If other researchers take up the different these research problem statements, hope in future we'll have a autonomous let's say autonomous vehicles will be there in the Indian farming.
Yes, that's.
So so thank you, Chaitanya, for accepting our invitation. Uh, we are from the CSMS family. We'd like to thank you for accepting our invitation and delivering your talk.
Mhm. Thank you so much for giving me this opportunity, sir. Even though I was not super, my field of working is not super focused in the farming industry. I more work on autonomous cars, but still, if I was able to provide the value to this program, I am very glad.
Yes, thank you.
Mm.
Yeah. So thank you all participants. Now we have ended both the sessions for the day 3. I have shared the feedback link in the chat box. So please submit the feedback for the today's both the sessions.
Thank you so much.
Yeah. Dear participants, the feedback link for the day 3 is shared in chat box. So to fill the feedback for the today's session, you can use it. So we are going to end the today's session. So good night, all of you. We'll meet tomorrow at 6 p.m.